Hi guys, this is review 2 homework question number 1. Let's get started. You have two masses M1 and M2 in an Edgewood machine, and they say M2 is always greater than M1, and in the first part A they are simply asking for the free body diagram. So once we are drawing the free body diagram of M1, what are we going to consider? Of course, the forces that is going to be acting on the object. M1 is going to have mg going down, and it's going to have Ft, the tension, going up. But we need to consider something in this free body diagram because they give a grid line, meaning you need to give the forces in terms of their magnitudes. So you're not going to draw any length, you're expected to draw a length according to the magnitudes. So since this object M1, M2 is always greater than M1, meaning this guy is going to be pulling down, so this guy is going to go up. So the total acceleration of this first mass is going to be going upward, meaning upward force is greater than downward force. So you are going to be drawing this Ft longer than your mg, and that's going to be the free body diagram for the first object. And once you draw the free body diagram for the second object, M2, you're going to have the same idea. mg is going down and Ft going up. However, you're going to have two critical things in this case. You are going to have mg going down, and since this is going to be moving downward, total force is supposed to go downward. So your downward force is going to be greater than your upward force. This is important. However, your upward force is also going to be related to the first one. So if you drew the first Ft as, let's say, two lines, then that should be also two lines, because tension in the same string is supposed to stay the same. So Ft is going to go up, and that is going to have the same length as the first one, because again, you're going to have the same tension in the same string. And since this guy is accelerating downwards, that's supposed to go longer than the Ft. So if you would like to draw it with the units, 1 unit, 2 units, 2 units, 3 units. That would be the way that you can actually figure that out. And that's part 1. In part B, they're asking for you to prove that A equals M2 minus M1 divided by M1 plus M2 times G. So they want you to prove that this is the way that it should be. Well, once we are solving this question, we can simply use system idea of ours. So this is basically two objects moving together. So total force that moves the system is going to be equal to mass of the system and A of the system. And when you think about this, Ft is the internal force, so Ft is not going to have any effect in the system. M2G will be trying to pull it down on the right side, and M1G will be trying to pull it down on the other side. So if you think about the total force of the system, it's going to be either the sum of those or the difference of those. But once you think about it, you will figure out that those two are not helping each other. As this guy increases, this is going to have less effect, less pulling effect, meaning when this force increases, the total force will decrease. So we are basically looking for the difference. So my force, total force in the system, since M2G is more, you can simply say M2G minus M1G is going to be equal to total mass. So this force, this total force, whatever that is is going to be moving m1 plus m2 mass together times it is going to be the acceleration of those two objects. For systems, every part of the system has the same acceleration because one cannot go faster than the other. Think about you're in a bus. First person or the person in the front is going to have the same acceleration as the one in the back. So it doesn't matter which one is ahead, which one is behind. They all are going to have the same acceleration. So what are we going to do? You have m2g, m1g, so you take this into g parenthesis, and then it's going to have m2 minus m1 equals m1 plus m2a, and we are trying to solve this for a, so you divide both sides by m1 plus m2, and m1 plus m2's will cancel out, so your a is going to be equal to, in part C, they are giving you the data over here for acceleration, and they also give you m1 and m2 separately. I didn't put that over here. And what they try to do is they're trying to find g, gravity of acceleration, by the graph. So what is a way to do so? So if you would like to do that, what should be graphing and slope of your line is going to give you g. So a way to do this for such cases, if you're trying to find an unknown experimentally, first thing that you need to do is isolate it. So if you would like to isolate g, what is a way to do so? So you have m2 minus m1 over m1 plus m2 next to it. So if you would like to get rid of, if you would like to isolate g, that means you divide both sides with this number. Then your g will become a divided by m2 minus m1 divided by m1 plus m2. So now I have what I wanted, because g, that's what I'm trying to figure out graphically. And if you would like to find something in a graph, slope of a graph is basically rise over run. So if you have an a over here and b over here, slope is going to be technically a over b. So it doesn't matter what a is, it doesn't matter what b is. But this a to b ratio must, or a over b is going to be the slope, and that must be valid for any number a, any number b. So I'm trying to find g from the slope. So a over b. So here my a, I just said a over b as like letters, but over here I have a as acceleration on the top, and I divide it with something complex, m2 minus m1 plus, over m1 plus m2. But it doesn't matter. So it doesn't matter what you have in the bottom, it doesn't matter what you have in the top. I could have like at squared plus whatever. That would not change the result. So your g, once you isolate it, it's a over this number. That means if you put a on the a on the y-axis, and then m2 minus m1 divided by m1 plus m2, then this ratio must be constant, and it must give me this line, because g is the ratio of this number divided by this number. Alright, so on my vertical axis, I'm going to have a, and on my horizontal axis, I'm going to have m2 minus m1 divided by m1 plus m2. So I'm going to fill this out according to this m2 minus m1 divided by m1 plus m2 values, And then what we're going to do, we're going to basically plot A to this, and the slope is going to give us experimental G. Alright, now I have calculated m2 minus m1 over m1 plus m2. Now I would like to talk about how you decide what will be the numbers on the axis, because that is critical to be able to draw a correct line of best fit. So a way for you to figure out, basically looking at your smallest number and the largest number and the difference in between them. And make sure you include all of the range in between your scale over here. So I start from 1 and I go up to 4. So whenever I count my spaces, grids, I have 1, 2, 3, 4, 5. So I can directly put 1, I can start from 0. And you don't have to start from a 0. 0, 1, 2, 3, 4, 5. So I'm going to have 1 starting from somewhere over here, and I'm going to be able to go up to 4 somewhere over here. So I'm going to be able to have all of my numbers somewhere in this range. And they're not in order, but it's not really important because you will see that this ratio is a linear thing. So first one is going to be over here, second one will be here, but once you put all of the dots, you will see that it's something linear. And whenever I look my mass differences, then I see that it is starting from 0.143, and the way that it goes up is 0.412. So what is the difference? And let me count how many points I have. 1, 2, 3, 4, 5, 6, 7. So a way for you to figure that out is basically look at the smallest number, again 0.14, and you go up to 0.41. So a best way is getting the difference, like 0.41 minus 0.14. So what is the difference in between them? It is going to be 7, and it's going to be 27. So you divide 27 by 7, then it's going to be roughly, what, 4? So you can, that means you can increase it, and we're talking about like 0.00. So that means you can increase it by 0.04. But to make it easier, instead of increasing by 4s, just increase it by 0.05s. So, and to make it even better, you start from 0.010, 0.15, 20, 25, 30, 35, 40, 45. And as you can see, you have 14 included, 41 included. So you're going to have something somewhere over here. So your graph is going to be somewhere over here. All right, now let's find all the coordinates of the point and let's place them on the graph. So what am I going to do? I'm going to draw the line of best fit. What is a way for me to draw a line of best fit? Line of best fit is the line that is close to every single point. So it doesn't have to go through any of the points, it just needs to go close to all the points. So once I look at it, I see that this is actually close to all the points. And then all you have to do is draw a straight line. Make sure you use a ruler for that. So as you can see, it is pretty close to every single point, and then this is going to be my line of best fit. In part E, you are expected to find the slope. Actually not slope, G, but G in this case is directly equal to my slope. So what is a way to find a slope on a graph? You need to pick 2 good points on your graph. For example, you can use those 2 points because you know the coordinates of those 2 points, and they are pretty much on the graph already. So let's do this, and I will be picking this point and this point. And it's better if you actually mark those 2 points, like with a circle, and then you are going to basically find, you're going to go down, and you're going to find that difference. So these are my maximum minimum numbers. So let's see what are the coordinates of maximum and minimum numbers. Minimum number is 143, so that's 143, and my maximum number is 141, so 0.41, so that's also 0.143, and that's 0.412. So the difference in between them is basically 9 and 106, and then this is 3, 2. So you can round this to basically 0.27. Alright, so this is my displacement, my change on the x-axis. And what's my change on the y-axis? You're going to do the similar thing, but this time you're going to go to the y-axis, y-coordinates. And again, these are my maximum and minimum numbers. So what are the coordinates for those 2 points? My minimum is 115, and my maximum is 421. So what is the difference in between them? So 421 minus 115 is 6, 0, and 3. So 306 divided by 0.27. So my slope is technically 306 divided by 0.27. And the result for this is going to be 11.33. In part Fi, this time they are basically changing the system. Instead of having a network machine, they're putting the mass M1 on the table. And the question is, what will be the tension on the string comparative to the first one? So to be able to figure that out, we need to actually remember what happened in the first case. In the first system, total force in the system was basically the difference in between the weights. But now you only have M2 acting on the system. And since M1G was retarding force in the first one, and you don't have that over here now, then your acceleration of M2, or the system, will be more. Because again, more force is acting on the system now. Because this guy is going to be cancelled by normal force that has no effect on the movement of the system. So acceleration will be more. So now, what will be the effect of tension on that? So let's consider the free body diagrams. Your free body diagrams will stay mg, or m2g, and in the first case it was going like this, ft, and that was like longer than this. And now what's going to happen, your m2g is still the same, but what should we have? We should have a greater acceleration. So what is a way to do that? So this difference is creating the acceleration. Now the difference in between the vectors will create the acceleration again. And what do we expect? We expect this acceleration, the new acceleration, more. And how is it possible? If this vector ft is less, then you are going to have basically more acceleration in the system. So the answer will be lower for part Fi. And for Fi, they find the g in this new experiment less than it was in the first experiment. So what is a way, or what's a possible way of explaining that? So if g is less, what does that mean? It's either A is less, or this difference is more. So you can have two meaningful explanations for that. You either have, you measure the acceleration, and what is the reason for acceleration? Total force on the system is your acceleration. So less acceleration means total force on the system is less. And what are the forces in the system? M2G. But here, what do you also have? Normally, we assume that this surface is frictionless. But if you have a little additional, like a little bit of friction on the surface, what's going to happen? This is going to retard the motion a little bit, and that's going to create basically less force as a system and less acceleration, so you are going to get less G. So friction on the surface retards the motion, causes less acceleration, and that basically results in less G.